Hey, what's up guys, my name is Cherno. Welcome back to the Game Engine series. We are back at it again on twitch.tv/thecherno, live streaming the Game Engine series. We had a break last week because I had a lot of critical Big Hazel work to do. And Big Hazel, by the way, if you don't know, is like the 3D version of Hazel, the kind of big product that we develop in a team, all thanks to your support on patreon.com/thecherno. And a lot of the technology from there bleeds, of course, into Hazel 2D. So if you want to support what we're doing, patreon.com/thecherno, best place for sure to do it. And you'll also get access to Hazel 3D. Today, we are going to be continuing on our scripting journey in C#, and specifically me and the stream in the little pre-show that we had, decided that what we would do is we would make it so that when we're adding scripts to our various entities like we have over here, what we would actually do is expose like all of the public fields. So at the moment we can basically type in and pick a class, and this is just a text field at the moment, not very good, but it's still better than nothing. What I want to do is to this kind of UI, I also want to basically add any field that we, create inside C# that is public, or in the future, I mean, like, truth be told, in the future, it'll probably have like some sort of, I think we have like an attribute called show in editor, right? So if it's either public or, you have your little show in editor attribute, and maybe it's private or whatever. This is becoming a mess, but anyway, we'll be able to just like display that field over here, like along with this name, obviously, and based on the type, we can make it like a drag float, or like a string input thing, or even an array or something like that, right? And that's going to be good because it means that, we can basically expose something that is supposed to be editable, like in the UI, as kind of like, I guess, game data, right? So instead of it being hard-coded, it doesn't have to be hard-coded, of course, because you can always just, write some kind of system. That's the beauty about C#. Like that's really the beauty of this whole scripting system in Hazel in general, and in any engine, right? It's literally a programming language. You can write your own anything. If you want to write your own system that, maybe even uses a UI tool that you've designed to handle data, such as like how fast my player should be moving, you can build that system entirely on top of Hazel and everything in C#, right? That's completely like doable, and that's actually something that, a lot of people do. Obviously, a lot of studios do when they develop games, like using something like Unity. They'll build their own systems on top of it. That's kind of a given, right? So you could do all of that stuff, but this is kind of like a built-in system, I guess, into the actual game engine that just lets you control your data from the UI. And also, it's not just for like setting the player speed. So for those of you who aren't really following, basically the idea is in my like player C# script, I can make a little public float or something called speed. And then I don't have to set it to anything inside C#, but what I can do is just physically use the UI over here to like, set speed to like 5 or something, right? And then that way, like, I don't have to touch any code ever, but also I can have like multiple, I guess, instances of player, multiple scenes or whatever. Maybe the speed is different and it's all serialized there, right? Like having those kind of variables are really quite useful. Well, we usually call them fields. Anyway, so the other really useful use case for this though is not just setting stuff. So in other words, you can like set the speed obviously to something like 5, and that's that. It's not just that, it's also for reading back stuff for like debugging purposes. So maybe I have an internal field that I use, to like, I don't know, calculate the velocity, and I want to see that somehow. Like, of course I can just print that to the log, or I don't know, maybe I can debug it with breakpoints or something, but it's also nice to be able to like hijack the editor UI and be like, hey, I can just display this vec3 velocity in the UI. And so if I like play my game and I select my player entity, I can just look at the data as it's like, I can just look at what that variable is set to live as I'm playing the game, right? And that can obviously work with anything. I mean, let's just say you have some kind of like is on ground system or variable or whatever. right? That's supposed to detect via a raycast or something whether or not the player is actually on the ground. You can display that boolean or state or whatever in the UI so that you don't have to completely, like, you know, continuously log it or do anything like that, or change the material color to red to indicate that it's on the ground or whatever. You can just do that using the UI. So that's really quite helpful in practice, and it's something that I want to add that kind of system in here. So let's begin doing that, because this is going to be a bit of a journey. As usual, I haven't really prepared for like any of this. So basically, we're gonna kind of learn this process together, which should be fun. So let's start by going to like the scripting engine, right? And the idea is, what we basically want to do is, and there's a few different ways we can do this. So let's think about the design a little bit. The really good thing about this game engine series for me personally, like one useful aspect of it for me, is that I get to rethink and challenge the design of Hazel 3D like all the time. No, Chico, it's not just for debugging. So it's kind of like in Unity, where you can just set, like, you know, your speed to 5, and that's going to be that. Basically what will happen is when the game starts, like whatever values are inside that UI that you've written, they're going to get set onto that variable in the script. So you don't have to set your actual data for your variables inside the C# script. You can do that via the editor UI. Anyway, yeah, one of the good things about this is I get to challenge my design, right? So like whatever design, and not just my design, but the team's design, right? Like no part of me ever claims to be doing things the correct way, because first of all, that's very subjective. That's very subject to change. And also, like, I don't know, like, what does that even mean, doing things the correct way? Like, you want to live life the correct way? Like, you know what I mean? Like, it doesn't make sense. So because of that, yeah, like if I think about the way that we're handling this currently inside Hazel 3D, I believe what we do is, yeah, I don't actually remember. I'm trying not to look at the code. I'm trying to like just think about it. But basically, like, the question we have at the moment is, how do we determine for every class that we have in our assembly its public fields? Because there's something that we can do inside Mono, and there actually might be a better way to do this than the way I'm thinking of, just because we have this metadata situation here. But there's definitely a way that we can just like, probably before we instantiate the class, if we actually take a look at this Mono class, so we get the class from name, and then we have Mono class. Like, there should be a way to like get, yeah, so there's get fields, yes, there's number of fields, right? So we can work out the fields that it has, first of all. There's also Mono class, I guess, get fields. There's get field, which we might be able to do by, let's see if there's field token. But there's get fields, which if we take a look at that, yeah, that gives us back like an iterator, basically, that we can use. And then, well, it will return the actual Mono class field for us, which is something we can use. But there also might be a way that we can actually get the fields using the metadata. I'm not 100% sure though, because look, we're getting the class over here to check if it's a subclass. So we could actually calculate all the fields here. But the thing is, like, the thing is, like, it also, like, I guess, depends on whether or not we want to immediately load all public fields and be aware of them when we load the assembly. So when the DLL gets loaded, do we want to do it then, or do we want to do it like when we actually instantiate the class? So when we start using it, do we want to query Mono to get all of the fields? I don't know, maybe. I don't know if I generally want to go through and retrieve all the fields immediately. Not that that would be that slow, maybe. Like, it might be... I just don't know if there's a point to that, because maybe you have a lot of... The other thing about this system, though, is that, remember, it has to, like, I know from experience that, obviously when you're writing something, like when you're working on a game, let's go and open our little example game and I'll show you what I mean. when you're working on a game, like stuff changes all the time, right? So for example, for this player, you know, I might have this like, I might have this player class that has like some kind of public float speed here, right? But then later, maybe that changes to a vec3 or something that's called velocity, you know, like stuff changes. And so if you know, if you preload, like if you load all of the assembly classes and you figure out all of their public fields, what happens if I do change the code, you know, from being this kind of float speed that we had, right? To being like public vector 3 velocity. Because if I do change that, then we might potentially lose that data that we had there for speed. What we do in Hazel 3D, I think now, is we basically retain that information. So we can kind of like still inside the scene, which is where these things get serialized in like the scene file, because obviously like the fields are applicable to an instantiated entity that is inside your scene. We store them there. So if we have something like that, then even if we do remove a public field, it kind of still, unless we hit like Control S or something and we overwrite the file, it will keep that value there, because we might not want to lose it. And this becomes like, we've had so many discussions with the team about this, because it does become like a question of like, well, what is the expected result of this, right? Anyway, I don't know if like the best approach for Hazel 2D is for me to talk through all of these like deeper problems. It might be better for us to just implement a system and go like the simple route first, and then see whether or not like that, you know, problems will actually arise from that and what to do in those situations. But yeah, I'm not 100% sure. I think the other thing to actually think about though is where these are actually going to get stored, these fields. Okay, let's not get too ahead of ourselves. I think step one is going to be, let's actually try and retrieve the data from Mono, right? So I want to be able to basically see, and I think, to be honest, I think I actually will do that when we're loading the assembly classes. I think that like, I think I probably want to, because it's either that or we could have a cache obviously, so that the first time you use a script, it generates like a cache of fields. But I actually think I'm going to do it here, at least for now, because that will probably be simple. So we've got get fields, we've got number of fields, and yeah, metadata. Is there a metadata function to get, you know, some kind of field? Oof, I don't know. I don't think so. Well, there is field info. I don't know if this stuff is actually going to be, this is the metadata header file inside Mono. I don't know if this stuff is going to be applicable to actual fields, or if these are fields within the metadata table. So that is something to ask. By the way, yeah, I noticed someone was asking about my Visual Studio theme. This is a custom theme that I made. It's based off of Grovbox. That's like the color palette basically, but I did modify it quite a bit. So it's kind of a custom theme, but I will probably release it soon. I keep saying that I want to play around with it a bit more and make sure that like I'm happy with it. Before I kind of release it, but like we'll see, because I think I've been using it without touching it for like weeks, so I think I probably will release it soon. Okay, so yeah, I mean, we get the class name. I think what we're gonna do is we're gonna use these two functions, right? And I'm not 100% sure how to use them. So if is entity, then we do this. Okay, so if it is an entity, we'll probably do the opposite. So let's just say if it's not an entity, we'll continue, because I'm about to do a bunch of stuff here. So once we do this, let's do, yeah, let's just get the number of fields. That's probably a decent, like start. And then I'm assuming we can just kind of iterate through them. I forget how to use this though. I remember this is a bit interesting because again, mono's documentation. Let's see if we can dig this up though. Because there is obviously, like there is some documentation. So we got like the mono docs here. The very bright mono docs. So we got mono class get fields. So this routine is an iterator routine for retrieving fields in a class. You must pass a G pointer that points to 0 and treat it as a opaque handle to iterate over all the elements. And the return value is null when there's nothing left. So basically, I think, so if we, let's like read this. Let's read this and let's figure out how to use this. So these are the docs. Because some of these documentation, especially for beginners, might be very cryptic, but it's okay. I'm here to struggle through it with you. Like, what the heck is a G pointer, man? Like, what's a G pointer? What is actually a G pointer? Oh, this is the G pointer. They've decided to have a custom type, but here it's just clearly a void, like double pointer. Anyway, what I think is up is basically you have this like iterator pointer, which they want to be equal to null first, right? That points to 0, right? So you have to pass a G pointer that points to 0. So this is a G pointer, apparently, that points to 0, I think. And what you do is you basically have your mono class, obviously, as your first argument, but then over here you pass in the memory address of this iterator, I think. Right? Eldry, thank you for the subscription. Appreciate the support. Yeah, maybe generic pointer is what it stands for. I don't know. The point is I have not heard of the term G pointer before. I don't know if this is like, you know, if this is like standard, but I've never heard of it. Anyway, I don't know if this is the case or the other alternative is, I mean, I guess there's not really much difference, but you could also just pass that potentially. You know, if you had your iterator too. Yeah. This just lets us modify the actual pointer, I guess, but ultimately there's probably not much difference. So if we do something like that, and then obviously this returns something, right? So it returns a monoclass field. So that's the return value, our little field. And obviously, the idea is that we use this to iterate over all the elements. When no more values are available, the return value is null. So eventually the field is going to be null, right? So what we can do is we can basically have our little field. I'll write this out a little bit more elegantly. And then we can basically say while field, we'll assign field to this, right? And then we'll also say does not equal null pointer. Alternatively, of course, you don't have to do this. You could just do while field equals that, right? So we're assigning field to that. And we could probably put this into the scope, right? If you wanted to. Or is it not going to let us do that? Huh. Maybe not. Really? Why would it not let us do that? Or do I just have... I just got one too many brackets. Actually, no, I don't, do I? No, that looks fine. There we go. Sorry. I don't know what's going on there. The does not equal thing, people keep asking me. It's just like one of those, I forgot what they're called. But it's just this font, ligature, I think. If you type in the exclamation mark and equals and put it together, it just makes it that. Same as like with less than equal to or greater than equal to. I don't know, I used to not like it. This happened like with Visual Studio 2022 automatically. I guess it uses a different font called like Cascadia Code or Cascadia Mono. And it does this now, but whatever. I actually kind of like it now, so there you go. All right, anyway, yeah, so you could do doesn't equal null, or you could just leave it like that. Okay, so the point is we get the field, right? This is the current field. It's in a while loop. Obviously, if it's null, we're not going to enter the loop, so That's basically, I think, how it works. And then what we can do with the field, right? So we get a monoclass field. So let's take a look at what API we have for fields. And if we go down here, we have field accessors, right? So again, the way I'm like, it's important to realize that, like, as a software engineer, like as you get better at software engineering, I guess, as you grow in experience, you know, you get used to code. And so the best way to find out these things is probably not even to read the documentation. It's just to be like, okay, cool, well, monoclass get fields gets me back a monoclass field. Let me just search the code real quick to see like what else there is for this, because this is a pointer to something. This is a C style API, right? So there's not going to be like, if we go to this actual, you know, class or struct or whatever, it's really just a pointer. It's just a handle to a block of memory that's going to enable us to retrieve data, right? And then you can see that if we scroll down a bit, we see a bunch of, you know, usages of this monoclass field, as well as a little comment here. And we can see that, for example, if we want to retrieve the name, we can pass in a field and it will give us back a const char pointer, which is going to be the name of that field, right? So, that's kind of how I'm using this, because I'm actually going into this blind, right? The whole point of this is I'm trying not to look at, I don't have like Hazel 3D open on this computer, on this monitor. Like I have the stream actually open here. I have stream chat here. Hi chat. That's what's there. Like I'm just doing this completely as I would do it for the first time. And believe me, it's been at least 3 years, I think. 2 or 3 years since I actually physically last did this kind of code using Mono. So yeah. All right, so we want to get the name. The type's going to be important. Get flags, get offset, get data. Now, I would like to also basically, like, we need to find out whether or not it's public, right? Also, these flags, like, that means nothing to me. Get flags into the UN32T. What are the possible flags? I have no idea. Like, get data. I wonder what that's going to do. But, like, yeah, we can probably find out the type, and that's going to be a monotype, right? I think, like, there has to be a way for us to actually ask what the kind of like what the I guess accessor is or whatever. What the visibility is. That's what I'm thinking of. So I don't know how we're gonna get that. I don't remember. And again, I'm trying to work it out. I'm gonna try and work it out live. So we've got the field, so we can ask it, as I mentioned. Let's just get the name. Let's just dump the name. So get name field, because that's going to be an easy way to identify it, right? We'll just grab the name, and then we can just be like, you know, so we've got the name of the class, right? So let's see if we can. So let's do this, and we'll do, so these are going to be all the fields for this thing, and then field name. So that's going to be obviously the class name. I probably should call it like class name. Let's go ahead and refactor some of this. And then we're going to have the field name, and then we're going to just probably dump like, you know, something like that, just so it's indented a bit and we can kind of see, or I can just probably replace that with the space. All right. Yeah, number of fields, like, I guess isn't useful if we have an iterator that iterates through it. But like if we wanted to, NISP RSA, thank you for the prime sub, appreciate the support. If we wanted to see how many fields we actually had, then we could obviously, you know, grab a field count. And we'll just say it has that many fields. And yeah, let's see if we could just hit F5, I guess. We'll see what happens. Hi, Cherno, how do you feel about the Rust language? I don't really feel things for it. I guess it's like, it's interesting, and I would like to take a look at it, but I don't have much time. All right, cool. So yeah, we can see that this code over here, or this like text over here, camera has 0 fields, that's cool. Player has 2 fields, M transform and M rigid body, right? So now we're already using this very simple code here that we added. This is all we've added today. We're able to actually go into the player class and see both of these fields. Now, obviously, they're private fields, so we aren't really interested in seeing them, but obviously they're here, right? And then if I go ahead and I add like that public float speed, and I build this, and then I go back into Hazel and I run it, then you can see we have 3 fields, one of them being speed. Very cool. So now I would like to get some like some info about these fields. Like honestly, like I have the field name, I have some basic data about the field, right? I can get the tag, I can get the type, I can get the flags and all of that, but I really don't know how to get the like visibility of it, right? And not even the visibility, but I'm probably going to want to get the attributes as well at some point. So we have get field by field token. We can always take a look. It's going to be hard this way, but we can also, like, one thing I might do before actually, because I'm thinking of looking at the mono docs, but before I do that, we can always take a look at like the actual header files that we have here, because that's going to have some stuff for us, right? There was that metadata one, but I don't know if I want to take a look at that. We can take a look at the metadata header file just to see if we have certain. So there's my method signature. Might just search for the other thing we might do actually is if I just copy this path. In fact, I might go back to just mono. If I just copy this mono path, which has all of my header files, I can go Control-Shift-F, and then I can, into my lookin, right? I can make it that directory, and then I can search for like, you know, visibility or something. And then that's just going to search that entire directory, and we'll see anything that matches that, right? Visibility might not be what they call it, but we might use that to look at like, you know, attributes or something like that. Yeah, it doesn't look like there's anything helpful coming in over here. Let's do another search for like attribute. There's a lot of attribute stuff here. So monoclass get flags and type attribute interface. Okay, so this looks like some stuff we could probably, yeah, monoclass is abstract. Looks at these tags, right? So we can see that there are some tags. These are probably for, I don't know exactly what these are for, but yeah, they're not really for. Oh, look, we have nested public private. Yeah, could also search for like private or whatever just to see if there's stuff there. Field attribute, field access mask, field attribute private. Okay, but that's an attribute. Oh, attribute. Okay, so I think attribute might not even be a C# attribute. It might just be an attribute of like a physical attribute of the actual field, right? So field attribute private. Okay, and look, public. Okay, but that's weird to me because why wouldn't it have like, what about it? What if it's internal, or what if it's default? Why is it specifically just public and private are appearing here? Are these just convenience functions maybe? And there's type attribute public. So there's field attribute public and private, but then there's also type attribute public and yeah, method attribute. Okay, so we can look at method stuff. This is interesting, this little table def. So I might just keep this open over here. And I'm guessing we can kind of get the field attributes or something. So let's see if we can do that. So there's get name. Yeah, I'm not really, the word attribute's not appearing here, but there might be a different way to get that. Let's go back to our search and see if there's anything else here. Object internals. Yeah, table defs we looked at. Yeah, but see, like, I mean, when it has these defs here, these defines, monotype instruct and stuff, like a lot of these things actually just do monoclass get flags, and then they compare it to type attribute. So see, they're using two different terms here, which is why it's a little bit confusing as well. And I personally wouldn't do this in my code. But we have like monoclass get flags, and yet one of the flags is something called an attribute. You know, why isn't this like a type flag interface or whatever? Or monoclass get attributes? Because otherwise this is like, it's weird. It looks like flags are a combination of attributes and also not. But also it looks like these are bit flags, right? Which is a bit weird. I mean, they are obviously, it does look like this is probably what we want to do, or at least one way of doing it. Again, mono is quite large, so there might be numerous ways to do this. But I think what I can do is probably get the flags from here, right? And then if I have the flags, I think this returns a uint32t. I think I can basically check the flags against what we saw there, right? So field attribute public. So let's just do this. Let's just do if flags and field attribute public. So basically this means doesn't equal 0, right? Why is this an error? So it's in table defs. So let's go ahead and include table defs. Whoops. So yeah, we've included table defs. That's cool. So if it's public, then let's go ahead and print it, right? And then also I want to just, maybe I want to print the flags as well. But let's just do this first to see if we get any fields printing. So I guess if this works, we just get speed. And yeah, it does work. Okay, so player has 3 fields, but you can see it only printed speed because the rest of them are not public. So yeah, but we can take a look at what other flags we have, because that's kind of interesting, right? So if I just duplicate this, come up here, and we'll say, let's do flags equals, and then we'll just do that. And then we'll say that is public. So we can take a look now at what we've got here. So yeah, transform flag is 1, rigid body flag is 1, and speed flag says 6. Okay, so 6. Okay, so yeah, so this is actually 6, and these are 1. So it looks like the only flags they have are basically, because look, the thing is, these aren't even flags. Like, well, I mean, they can be flags. It depends how you define flags, but they're not bit flags, obviously, because they're just ascending. But we have private, so 1, and then we have public, which is 6, right? So those are the only flags set on those fields, which is, I guess, interesting. Anyway, we've achieved what we wanted, right? We can now basically say that if flags and public, we could do the opposite as well. Then we can basically add this as a flag. Now, the next thing we need though, so let's kind of keep this here. Because the next thing, we're not quite done yet. What we want to do is we want to also make sure that we can get the type, right? Because the type's going to matter. Because first of all, we're not going to be able to just, you know, potentially deal with every public type. So what if it's like a complex type? What if it's a class, right? We're probably not going to handle that. Like in terms of the types that we support, there'll probably be things like float, you know, vector 3, well, basically any like type that we legitimately support. If someone like has a public, I don't know, file stream or file writer or like, I don't know, whatever class, like obviously that's not something we want to be able to add using the UI, but if it's like a primitive type or some kind of like math type or you know, or other things, like maybe it's an entity, maybe it's another entity, maybe it's a prefab, maybe it's an asset, right? Kind of built-in Hazel types. That's obviously something we should support. So we really need a way to just be able to look at this and be like, okay, what type is this? So monofield get type obviously returns back to us. I think it's a monotype. Yeah, and there's like, the thing with monotypes is that they're a bit complicated because look, we have the type name, but then we've also got stuff like get underlying type. So I'm not 100% sure if this will get us what we want. But because we can actually get, you know, do monotype get name, for example, and get name full. Let's do get name for now. Let's do monotype get name, and we'll just type in type here, and then I'll just put in brackets, I guess, the type. Let's see what this gives us. Okay, so yeah, so speed is system.single, which is cool. If I, for reference, if I come over here and I just do public entity, like other entity or something, let's build that. So we should be able to get, that should be like a Hazel entity, and that way we'll be able to obviously see, right, that it is in fact a Hazel entity, and we can do stuff with it if we wanted to. Because like, and the reason that's important is because like, well, in Big Hazel, for example, one of the things that we support and we do quite often is we might have like, you know, an entity field here, and what you can actually do is you can grab like one of these entities here, and you can actually drag them in to like the field, to the entity field inside the script. And that's very, very useful if you want to be able to have this script interact with another entity, for example. So therefore, like, you might want to do that. And obviously you can maybe interact with the script directly even, because if you, you know, if I had like, instead of public entity, you know, maybe I'll have like public player or public camera other entity, then camera is an entity, and therefore we can also support that behavior if we wanted to. So we can check for it that way. But for now, like, you know, we can have something like that, right? And so, for example, with that, you know, float thing, what we could do is if we just get the name, so const char type name is that, right? We'll leave the logging there for now. We could say, for example, that if, well, you know, depends how you want to do this, I guess. We could have like some kind of map, you know, that converts that monotype into like a Hazel type. Because I don't really want to obviously deal with it as a string and whatever, but we could have something like if we just take a look at you know, we have this utils section up here. Let's just quickly make something here that's just like, if I go to script engine, let's make a like a, I don't know, an enum class, you know, field type or something, right? Script field type. I'll be precise with my naming. None as usual, because that's how I roll. I always like to have a little none at 0, and then we can have like, for example, you know, float. So float vector 2, vector 3, vector 4, and then maybe we'll have like int. I don't really care about the other ones. Unsigned int, you know, bool. What other data types are there, guys? You know, we might have like double, short, byte, you know, whatever. You get the point. We have a lot of these things, right? And then we're gonna make like a little script field type. I really shouldn't have this here probably, but script field type, we can call this like monotype to script field type or something. Well, it's actually not really a monotype. Well, no, we could, if we wanted to, we could actually just take in a monotype to make it even like easier. And then we can grab the type name from the monotype, and then we could do like basically a little, I mean, we could have like, we could just have a mapping, right? So we could have like some kind of static std unordered map of const char pointer to, like, what was it? Script field type. And I think what we can do with this, you can kind of const expert it, I guess. So this will be like, what was it? System.single. I'm not sure if this will work though, actually, because I don't think, Well, no, actually, it might, because it's an unordered map. They might have a specialization for it. Let's see. I don't know if this will work, because it depends how it compares this pointer. But we'll do script field type, you know, float, for example, right? So the idea is you can have, like, you know, a bunch of these things. And then obviously you could just return that. And then we could have like some kind of core assert or verify, you know, type name is what I meant actually. And then we just return that. Yes, I am going to push this to the repository, of course. Okay, so monotyped, yeah, so we've got that kind of script field type. That's good. I don't know if that will work, as I mentioned, but we can always try. So let's do another utility function in a minute. So let's do, for one, we'll do utils monotype. So this is the type to script field type. We'll get rid of that. Now we have a script, like a Hazel script field type. From there, and now what I'm going to do is I'm going to use another utility function that's going to be called field type to string, right? And that's going to take in that, and it's just going to give me, you know, a string basically. So let's go ahead and fill that in, and I'll probably move this to some kind of header file in the future. So let's do const char. It could be an std string, but it's going to be compile time, so I like using const chars for that, I guess. Const char, what was it? Script field type to string. Yeah, actually, is that what that's not what I called it. Yeah, script field type to string. So I match basically, obviously, the name here. Script field type. And this is just going to be a switch statement where basically we have like case. This is the kind of thing that just exists in the language, like in C#, but in C++, you have to do it yourself. So like, if it's float, you know, we'll return float. You know, we could return invalid or something if we wanted to. Whoops. Forgot the return. That's nice. Alright. Hey Cherno, would you say PHP is still solid to pick up for getting into backend development? Ooh, web dev questions. Well, if I was serious about backend development, I probably wouldn't use it. Just because there are probably better things out there. I would probably use something like Node.js maybe. But that being said, I do use PHP a lot because it's by far the easiest thing. Like, you just make a .php file on your server and you just write like 5 lines of code and you can do like anything, right? If you need to set up like a Node.js instance or something, like that's a pain. Well, at least it is for me, who's not a web developer and always has to like look up how to do it every time. Like, PHP is just so easy. So, but yeah, if you have to build something sizable and you're in it for the long term, I probably would not use PHP, no. All right. So, basically, if this works, right, which I don't know if it will, this should actually, instead of printing system.single, so last time we ran this, right, it printed system.single. Now it should print invalid for this one and float for this one. Yeah, or we'll get that. Okay, so system.single, yeah. So as expected, it's not going to quite work. What we could do though, if we wanted to actually, is we could make this a string, and then we could, I guess, that would be like a, you know, we could make this a string. Might be a little heavier on the processing, but that should work. Yeah, it did. So if it basically, instead of asserting, if that doesn't equal that, then we want to return basically script field type none, right? Because that's like our invalid state, I guess. We either do that, or we can have like some kind of if statement with like stir or something. I don't know. Something like that. And that will, yeah, that'll work. Okay, cool. So yeah, there you go. Right, so as predicted, speed is a float, other entity is invalid. Now, obviously invalid is not what we want, but that's just like the current situation, I guess. Yeah, so we might have like, we'll have like entity and prefab and all of that stuff in the future. Entities we have now, prefabs we don't. So I'm just gonna, you know, this will be like a hazel.entity, and that will return entity. Let's go through and fill out the rest. I'm just gonna pop this over here so I can see. So float, and then we have vector 2. So vector 2 is gonna be hazel vector 2, hazel, vector 2, vector 3, vector 4, vector 4, well, vector 4, 2 and 3. Then we got int, uint. I don't remember the types though, so I don't think it's gonna be this, but we'll see. Oh, and long types I forgot about. Bool, it's probably not that. Well, I don't know, we'll see. Double, it's easy to find out. We've got entity, we should probably try and do this in order. So like byte short int long, and then ubyte, I guess. Bool we can just stick here. Ubyte, ushort, uint, ulong. Was there one more thing that we were missing? No. Byte short int long bool, byte u short uint ulong entity. Don't know. I feel like I'm missing some types. Byte short. Well, I already did that. Oh, whatever. And yeah, I'll probably have to adjust these because I don't remember the exact types. Double. Yeah, I should probably do. Let's do all the primitive types first, and then we'll do these, right? Because these are hazel types. So these are the primitive types. So single and double, byte short int long. I might make bool the first one. That maybe makes more sense. Short int long, so those are the main integer types. Then let's have the unsigned ones. So ubyte. Ubyte, u short, uint, and ulong. And then we got vector 2. Yeah, okay. So that I think is it basically. So those are the kind of built-in system types, which are probably half of them are probably wrong. And then yeah, that's pretty good. Seems quite cumbersome defining every type by yourself again. Is really needed. Yep, absolutely. Sharon, remember when you said eventually want to release and sell a full game developed in your game engine? Do you already have an idea what? Yeah, I do. I'm not going to talk about games right now, but yeah, we are like in pre-production for something low key. But we've got some. We basically want to ship some free games, like, you know, properly on Steam and everything. Not exactly original ideas per se, but we want to release some stuff, so that we can, you know, just make sure that Hazel works properly and you know, everything is good before we, like, you know, release an actual big game. But we definitely do have plans to do that one day, of course. All right, cool. So that's good. We've got all our types, which is nice. Again, we're not going to use most of them, but yeah, if we check this out, and half of them probably not going to work, but this invalid should hopefully now say oh no, it's not going to because I didn't make my 2-string thing work, did I? It's here. So let's do this quickly. So we got float and double. Bool, byte, short, int, long. U-byte. Oh yeah, I guess I can just copy this and then stick a U at the front. And then we got the vectors types. And then entity. And then let me just arrange this nicely. And I think we're good. All right. Entity. Yep, cool. Yeah, I probably should do what Kronos is suggesting, which is to not look up the map thing twice. How do you, I guess I can I do a const? Because I don't really want to, what's the syntax for this? I hate using iterators, to be honest. I never do, that's why I have no idea what I'm doing. That's not really what I wanted, but whatever. I mean, yeah, like. Anyway, you can see why I wrote it the first way. Let me know if there's a better way to write that, though. Like a more modern way without doing second like that. Okay. Yeah, so that should be good now, I think. Like, as in we should get our entity just like we did before. Beautiful. Yeah, so things I'm confused about, or things I should double check, actually, is basically all of the types, right? So we should validate that. We might as well, right? So let's do like byte, bool. So I might just let's duplicate. We'll come back to that. Let's just duplicate this. So byte, bool, short, int, long. What's the, it's probably a char, actually. So byte's probably the unsigned one, right? And then char's the signed one. Double we don't have. String we should probably also support. How's that looking? And the vector types, I might not do the vector types now because we don't even have half of them. I mean, we can do vector 2 because I think we made that, right? Okay, so we've got a bunch of these. That's all built. If we come back here, let's get it to, say unknown, unknown type, and then type name. Because that way we'll print everything that we got wrong. Why not use uint8t? Well, what do you mean? Where? As a string or as the type name? That would be a bit weird. This is C#, so obviously I'm not, like, those don't exist here. Like, I could use these ones. Like, they obviously don't have the _t stuff. But these are the kind of standard ones, which they probably map to anyway. Oh, there is an S byte. Okay. So what's the difference between a char and an S byte? I guess they're the same. What did I have this at as? Okay, so let's see. So, okay, so it's boolean, then char. Yeah, and see, these do map to int63. Okay, good. Yeah. I had a feeling they would. Because I know those also exist in C#. So we could change our naming for it as well. So that's boolean. So byte. Was there a byte? I guess byte is valid. No. Yeah, byte is valid. But char is char. So let's make a char type. So byte is valid, so short is an int16, int32, I think is that one, int64. And then we have the same but unsigned. Wait, what did I just change there? Oh, I duplicated it. So that is a... I think that is what a byte is, though. Okay, so uint16, is that right? Yep. 32. 64. Okay, that looks good, I think. Yeah, so we could change our underlying name, but ultimately it doesn't matter. I guess we probably will, because I do prefer this, I think. Well, I don't know, actually. What do people usually use? Okay, so they're all valid now. V1 is still invalid for some reason. So it was V1. But also it's not telling us it's invalid, strangely. Oh, well, actually, we might just not be two-stringing it. Yeah, we probably aren't two-stringing it. I think that's char. Because I just added that one. Yeah, cool. All right, that looks good. So just clean up some of these open files. What do we do now? So we've got the types. Right. So yeah, so what we could ultimately do now that we've got the types, like the next stage is going to be to like think about how we're going to store data for these types. Because, like, I mean, at the end of the day, right, if we take a look at our components, we have obviously our script component. Now, I would go as far as to say that, like, I mean, ideally what we would do is we just be like, hey man, here's a vector or a map or whatever of like your field name to like its value, right? I mean, that's kind of what you want to do, really. The reasons why I wouldn't do that is because, first of all, like, storing anything, like, you have to be careful about what you store inside components, because components are delicate. Components are part of, obviously, your entity component system. You want to be careful about the size of each component. We actually talked about this back when we did like the pull requests, I guess. You know, we looked at like someone who had taken the transform component, I guess, and had added like a whole bunch of stuff, I think, to it. And I talked about why that was bad, right? This is bad because it's also like, you know, the backing is going to be like a heap allocated block of memory. So if the entity component system decides to readjust this, I mean, it'll probably move the memory, so it probably won't be that bad, but it's still like, I feel a bit uneasy about having complex data structures inside my components, right? Like, that's not something I want to do. And don't forget that, like, as oh, a wild Peter appeared. As like, I guess, a software engineer, you know, if you think about like what you're trying to do here, at the end of the day, you know, you are just trying to have some kind of storage space for some data, right, inside a memory block that is related to this particular instance of a script component. So where you, like, the semantics between how you deal with this block of memory are so flexible that you, like, could do it 1,000 different ways, right? But the point is, like, what I could do is I could have, instead of like putting this block of memory in line, you know, in my component here, and then, you know, being a unordered map, having it point towards another buffer of actual data somewhere else, what I could do is have a different system where I store everything, like somewhere here. Let me draw it here, because my face cam's in the way. That's the chat, I guess. Sorry, chat, I'm gonna draw it all over you. I could have my little block of memory, you know, over here, and then have like some kind of external functionality that says, okay, well, for this script component that is part of this entity, you know, let me just retrieve its, let me like access its data, which is all designated within this block. You know what I mean? Like, we don't have to store it in the components. We just need some way to like relationally store it, I guess. Like, we kind of just need a way to be like, let's have this block of memory somewhere, but I can access it by, well, yeah, like people in chat are suggesting, like, I could use the UUID of that entity to look into a different buffer somewhere else that isn't even part of the entity component system, that's going to contain the actual, like, concrete data for my actual entity, like, fields, right? So the way that you design this is kind of obviously ultimately up to you, and it depends, like, it depends, I would say it depends on the hottest code path. And what that means is basically, like, you know, when you're writing code, you have to think about how it's going to be used in terms of like the hottest code path, right? So in other words, like, what I mean is, what is the most common use case for you accessing this data? Like, if you had to, like, if you made a game using this engine and you, like, you know, were running that game and you were playing that game, then how would this data be accessed most often, right? Like, what would be the hottest code path there? And that oftentimes is exactly how you want to design that system. Because otherwise, if you like, and to be honest, like, a lot of the times that's not an easy question to answer. Like, it's hard sometimes to be like, okay, how is this going to be used? Like, a lot of times you don't know. You might have one assumption, you might be wrong, right? But then, you know, you might think that it works a certain way, but then you might, you know, take a game that someone has made using your engine, or maybe you've made a game yourself using your own engine, and then you profile it, and then you find out, oh, whoa, actually, you know, it's only used like a couple hundred times per frame using this code path, but actually the majority of the access is this, and that's like 1,000 times per frame or something. And of course, like fundamentally, like it can vary game to game as well, which is why a generalized engine is such a difficult task, right? It's just such a difficult challenge to try and make something like that, because there are just so many different use cases and you just can't optimize for all of them, right? And so you have to start making generalizations, and that's usually where software quality kind of falls. So yeah, like there's a lot of like possibilities for how you kind of want to do this, and I believe in Hazel. Like Peter, by the way, I've been trying not to look at Hazel today, like not to look at Hazel 3D like during this stream. I'm just trying to do it like independently, so don't help me. Yeah, like I'm pretty sure Hazel 3D has some kind of a system where, yeah, we just have like some kind of value storage or some kind of you know, offshore bank account. I was gonna say like some kind of like offshore memory block that contains all of our kind of fields for something. But we do need a couple of things though here. Like I would say the first thing is, as we iterate through all of these things and we retrieve everything, right, we do want to know like for any given class, because like for example, you know, if we look at like the player class here or the camera class, maybe the camera class is a better example, though it doesn't have any public fields. Let's look at the player class, which has a lot of public fields. If we have like this player, let's go back to just having the speed. We might have, I mean, player is probably something you have one instance of, but maybe this is like enemy or something, and you have like 500 instances of them, or at least you've positioned different enemies in the map, and maybe this is not something that gets created via a prefab system. Maybe this is something that you've hand placed these enemies around your map, and you want them to have different attributes, and those are all different public fields, right? So you have kind of 10 instances of that enemy class. So I want to be able to, every time I instantiate that enemy class, if we think about it, right, I kind of want to be able to go to that enemy class and be like, okay, what are all of your public fields? Because now what I'm going to have to do is create storage for all of those public fields, basically. So that's kind of like step one, right? Being able to do something like that is very important. So the way we would do that is, you know, we already have this kind of script instance thing, right? And that is kind of a wrapper, like that has a script class, and a script class, as you can see, has a namespace, has a class name, and what I'm going to do is I'm also going to give it some fields, right? Now this is not the data for the fields. These are like field definitions. All I'm doing here is I'm saying basically that we have, and how you do this is kind of, I guess, up to you. What I'm going to do at the moment, though, I think, is I'm going to give it a string. We're going to just use string as a key, because obviously the variable name has to be unique. And then, I don't know if I want this to be an unordered map. It could be an ordered map. Like, it doesn't really matter. An ordered map might be easier for debugging, but like performance-wise, there's not going to be any difference, really, I don't think. But if we have a map, let's make it an ordered map just for fun. We might have like some kind of like, you know, script field here, and this might be something else. So we might have this, we might call this fields. And a script field, maybe I'll make it a struct. That's obviously going to have a type. It might have a name internally. I don't know. It's you don't have to have a name here. We could even make this a set if we make this have a name. But like, sure, why not? We'll have a name. We'll have the type. This might be a little bit redundant, as you can see, but whatever. I mean, at this point, we could probably even make it a vector. Again, see, this is what I mean. Like, when we try to decide between a map and a vector, it depends on the use case. Like, are you going to be directly addressing it? Like, are you going to be asking it for the field by name? Or do you just want all of them, right? And to be honest, I feel like we probably just want all of them, to be honest. Like, The only other thing here is that obviously it's going to make sure that we only have one of each name. We can't have duplicates. So it's going to be like a kind of unique set in that sense. But whatever. So we've got name, we've got type. That's going to be good enough, I think, for me. Let's have type as the first one. Okay, so what I want to do is, basically what I want to do is, so this kind of script class, I believe, is something that we kind of create this, right? So when we go through here, you can see that we do as data entity classes full name equals create ref script class. So what I want to do is make ref script class just be out here, right? And this is going to be our script class that we add into here. And then that way, obviously, as you can see here, I can go in, and this is part of the script engine. So let's just go ahead and make maybe the script engine be, yeah, we'll make it be a friend class. Script engine. And then that's going to mean that we can now, if it is public, you know, we can just say script class fields, you know, push back or in place back or whatever. Actually, no, it's a map. So we'll just do fields, you know, field name equals, and then I kind of want to make, so it's just I mean, this is just type and name. So we can just type in, you know, type, which is field type, and then name, which is field name. All right. Okay. So basically what this means, so if we go back to camera, I just want to make it so that we can have multiple of these really. But if we go back to the cam, so this is our script, we have other entity. Let's go ahead and put other entity in camera. Not that it does anything, but we have a public field here. We have a public float speed here. If we go back into here, back into Hazel, we can make sure probably that we're storing all of these. So where did these get? These go into entity classes, right? So if I go to the end of this, I just need to do this, otherwise it will be upset because the debugger sometimes doesn't know what sdata is. If we take a look at entity classes, right? So we have, it might be hard to see here, but we have sandbox. I mean, I can kind of zoom in, but every time I hit control, it goes that color, which is amazing. Anyway, sandbox camera, sandbox player. And then if we go to like camera, for example, we can go to the fields. See, we have one field, right? And then the type is 16. And the name here, it says, is other entity, right? So we got that one. And then if we look at the player also has a field, one field, and the name is speed, right? So now we, per class, know what fields, what public fields we have inside our scripts, which is pretty cool. So now it's just a matter of knowing how to set their data, right? So, excuse me. So at the moment, if we take a look at our little mini game, we can move this guy around. Now, the way that this guy's moved around, the player's moved around at the moment, is, yeah, we have this kind of speed variable, the 0.01, right? So what we can do instead is we can obviously just use this speed variable. So that's going to be our little test, right? So if I do that at the moment, we obviously don't run this. Let's just build that. If I do that at the moment, then you can see I'm not moving, right? Because the speed's going to be 0. But let's see if there's a way for us to actually read that value from mono and also write that value like into the runtime, right? And of course there is a way, otherwise none of this would work. So there is like, so we have runtime invoke. I need to figure out how to, yeah, I don't remember this at all. But there is going to be something. So object. Aha. There's definitely going to be something here, right? Aha, property set value, field set value. So field set value, right? And then there should be a field get value. Field get value, object field get value, right? So these two things inside the object header file are what we're gonna use basically. So let's try this out. Let's do mono field set value. I mean, we could do get value, whatever. Maybe let's do get value first. So if we do, let's kind of do it at the end here. So we need the object. So this needs to be an instantiated object, obviously. So let's take a look at how we do this. So we obviously call instantiate. This gets us back this object. So instance, so script instance becomes something that we do here. And then we invoke on create. We do all of these things. So where do we actually create script instance from? So this is probably something that we create from. So on create entity, creates script instance and does invoke on create. Where does this instance go? Into entity instances by entity UUID. Okay, interesting, cool. So at this point, let's see what we can do. Let's do this. Let's have some fun. Let's go to the scene hierarchy panel. Let's find the script component. And what I want to do is basically this. I want to do, so script engine entity class exists. Let's see if we can do script. So if that's all set, right? Fields. Let's go ahead and, so I want to get that like instances thing, right? What is it called? So script instance. Yeah, so that's not exactly a ref for some reason. I think we made it up here or somewhere. Yeah, okay. Oh no, it is. Wait, oh, because refs are shared pointers. Yeah, I just looked at this and I saw it wasn't ref counted, but this isn't Hazel 3D. This is Hazel 2D with the shared pointer system. So basically what we can do then is let's make a function here, a static one, called ref script instance, get entity script instance, and we'll pass in the entity ID, right? And then what this is gonna do is where is that thing? Yeah, it's basically just gonna look this up. All right, so we're gonna get that entity script instance. We should have it. It hopefully shouldn't be null. So now we can do script engine get entity script instance by the UUID. So we should have somewhere here, we should probably have the entity ID. I mean, we might not, or we can probably get it easily. Yeah, get UUID. So that's our script instance. And then if that's not null, then let's go ahead and basically try and get like the fields. Sorry, that's a script engine. Let's try and get the fields. Oh, sorry, it has a script class, which we can use to get the fields, right? So let's do get script class. And that's gonna have the fields. And I mean, just as simple as that, we could hopefully display the value. Right? Very easy. So, basically in that scene hierarchy panel, if we get script instance, so we're going to have to get the script class, then we can get the fields, right? And okay, yeah, we're gonna have to add some stuff here in a minute, but this will be a good starting point. So auto fields. So let's go through const auto. So how are we storing the fields against string? Okay, so name, field, and fields. So if field.type, let's just do floats for now. So we'll say if the type is script field type float, then yeah, then let's do this, right? So let's do imgui drag float. We'll just do 0 for now. And we'll give it like name.cstring will be the label, and then data here is what I'll use. All right. So we're not going to be able to actually read anything or set anything. So this is what we will do. But what's going on here? Entity cannot be implicitly captured because no default capture mode. Oh, it captures it. Does it capture it? Isn't that? Oh, I see. That's fine. Can I convert this? What was the error? Can I convert this pointer from const hazel entity to hazel entity thing? What are you talking about? Oh, maybe because that's not const. Well, let's just mark this as mutable, and that might work. I'm not interested in changing the value at the moment, so I haven't made the float static. This is just purely to get it to show up. So yeah, so if we click on sprite now, we won't see anything because it is in fact null. But if we hit play and we click on sprite, which is our player, check this out. We have speed here, right? And we're obviously reading this speed in from the script, right? So the value here, don't worry about the value, but the name and the fact that it's even there is actually being read in, you know, from the thing. And I can prove it because if we go back to obviously our assembly in player, you know, my other float variable, and then who's been active in chat? bgod5797 and script exec. You know, if I, if I build this and then go back to Hazel, you know, load this in, hit play, look at this, then you can see now that we have all of those floats that I just added. They're all appearing here, right? So that is great. That's step one. So what we want to do now is, well, we just need to be able to like hopefully set that variable, right? So to do that, again, we know that we have that. Well, actually, let's cover retrieving it first. So to retrieve it first, if we go back to Hazel, we know that we basically need to call. I mean, like the way that I would like to retrieve it probably is just be like, hey, script instance, I want to get, you know, my field value maybe as a float, right? So get field value float, and then we can obviously like run that for. So if it's a float, we can do get field value float, and we can pass in, hopefully, like some specific field. So we might do it by name. I don't know. I'll just do it by name. So back in script instance, if I write that, so template type name T is just going to be used as like a little casting thing, I imagine. I don't know if it needs to be whatever. get, we'll see if we add any special source to it. But basically, like at the end of the day, obviously, what we're going to call is mono field get value. So what do we need here? We need the object. So that's obviously going to be the actual instance. And sorry, I'm adding this into the wrong class. It should be in in script instance. So this actually has the instance, which is what we're looking for. So m instance we need. Then we're going to need the mono class field. Right? So we know that we have a bunch of fields. It's inside script class. However, what we need is the mono. This is a mono class field, I believe. So I don't think we're actually ever getting that. So we're getting mono get field type, but mono class get, oh no, here it is. So mono class field pointer, there it is. So let's make sure that we store this somewhere. And since we're storing everything inside this little struct here, it means that we can obviously add in mono class field, right? And then I'm gonna have to also make one of these guys for it, because I don't want to include mono in this thing. Although actually, if I've got this here, we might have to include mono. We can probably, no, we won't. We'll do this. We'll do, because the only reason this is a template is to cast. So we'll do void get field value internal, and this will be a private function, and this is what we'll call this, and that will just call that. And basically what this will do is, assuming value is not null, this will, which we should check probably elsewhere, but I guess this will try and dereference a value like that. And on it, again, copying it, for primitive types, it's not really going to matter. Actually, for any types, I don't think it's really going to matter too much, but we will see. Peter's recognizing this code. Yeah, this must have been very similar to what I wrote years ago, because I do remember this kind of way of doing things. All right, so get value, and then we need the field. So this is where we ask the script class to give us its fields. And then we can basically do fields.find name. So if it, and if this, at this point, obviously, if this is the end, then we can just return null, right? Otherwise, we know we're good. So we can do script, what is it? Script field. Let's do a const script field equals iterator second. And then we'll do field dot class field, and that's our class field. And then finally, it's going to give us a value out, I think. So this is going to be a void pointer. So this is kind of going to be our result. So we're going to type in void pointer result. We're going to pass that in here, I guess. And then we're going to return, that doesn't make sense. What? So get value. Oh, okay, I see. So this needs to be a buffer then. Yeah, because it's not going to give you a buffer. Okay, well, we know at the moment this is only going to support floats, but otherwise what we'll have to do, this is a bit annoying, isn't it? let's do char buffer. What's our biggest type? Well, because yeah, this will have to be like some kind of scratch buffer probably. I probably don't want this to be on the stack. It could be because we're going to copy the result out. But let's do a little inline static char. We'll call this field value buffer. We'll make this, how many bytes? Well, I guess 8 bytes, because that's going to be the largest data type we support at the moment. And yeah, this can probably just be static, because we don't need one of these per thing, I guess. as long as it's like on a single thread anyway. So we'll basically have to pass this in, right? And then we'll dereference it, cast it to that thing, do whatever, and then hopefully, of course, that will work. So now we've made it so that this takes in, you know, a buffer, which we pass in here, and I mean, we could return it, but I guess we could return a boolean or something instead of this. That might be better. Success. And then we can do something with that if we want. So maybe we can do something like, if not success, can we just do like return T? Otherwise we'll do that. So we'll just return like 0 effectively or whatever. So return false, return true, hopefully, and obviously that buffer is where it's going to copy that data to. So that's get value, right? So let's go back to scene hierarchy panel, and what we're going to do is script instance get value as a float. That's going to be our data here that we get, right? So let's see if we can make this work. So if we go back to sandbox, okay, so this doesn't even work because values, yeah, not declared. So I guess we'll have to do that, which is fine. But if we go back to sandbox, I just want to set like a value for this speed. So maybe on construction, just to not do it up here, let's set this speed to be like 0.25, right? That's like a number. Quote Cherno, 0.25. That's like a number. All right, so let's run Hazel now and see what happens. I don't know if that'll work. Probably should, right? I just mean, I hope I've added enough error kind of handling and whatever, so that, yeah, if it's not running or whatever, if I click on sprite, yeah. So we don't see anything here, but if we hit play and we click on sprite, okay, yeah, that's kind of what I was expecting, not gonna lie. So, what happened here? So get value, tried to get value internal. Let's see what these, oh, this is null. We never set this class field. Yep, I remember. I remember failing to remember to do that. So over here, where we actually set the field, we need to make sure that this field class thing actually makes its way into the struct. Okay, so there you go. Hit play. Now we click on player or sprite, should really name it player, and then check this out. 0.25. Beautiful. So we're now reading this, right, from mono, which is pretty amazing. Not only that, but check this out, guys. You know how I was talking about debugging earlier? Well, check this out. We have a velocity variable, and we're obviously setting that based on this, right? So what we can actually do, well, actually, let's do this instead. We're taking in this time step, right? So what I can do is I can take this speed at the moment, which is, I mean, we're kind of using it here. Let's maybe just set this back to what it was before. Actually, no, let's do this. Let's make another float. We'll call this time step, right? We'll just label it like that. And we'll set time step to the TS, or in fact, let's do plus equals TS. And let's call this time, so that way it will change a bit more. So we've got our time, right? Which we increment by TS. Now, if we go back to Hazel, then let me actually, you know, one thing I could do, just to make this a bit easier, because I feel like you guys in stream are probably suffering with the lack of being able to see anything. What we could do is we could just do this little font size ×2, and then that way it will just make the whole UI bigger. Right, so now we can kind of see, hopefully you guys can see better. Let me know if that's better. But if we drag this in, there's our player. Obviously the padding isn't like, you know, matching the font size or anything, but there's our player class, right? So if I hit play and we look at our player, which is our sprite, check this out. The time is increasing, right? So we can now read back variables from our C# runtime over here, just like that. And you can imagine the process is going to be very, very similar for, like, you know, other variable types. So yeah, pretty cool, right? Now let's set them, because I mean, if, you know, we've done all the work to get them, we can just set them, and hopefully that'll be as easy. So we've got get field value. So the idea is we're going to drag float, and then if this value actually changes, right, this is at this point that I want to basically say, okay, let's do script instance set value name. Sure, it can be a float. I don't know if it has to be, but we'll see. I don't know if this needs to be templated, because we could just pass in like a data pointer or whatever, but I guess float will be, I think it'll be nice if it's templated. In fact, we can just make it an implicit template as well. And then we can put in this data, right? So set field value. So let's check this out. So we've got get field value. Let's do a set field value. And then set field value, we'll take in a name. We'll take in, I guess we'll just do const t value to avoid copying in case we use bigger data types later. And then I think what this will do is it will do set field value internal. And then it will probably just be able to take in the memory address of value and pass that in. And then, I mean, I guess it can return success or something, or just, I mean, I don't know. Like, that's really all it has to do, right? So we'll do set, I guess we can, yeah, return a Boolean here as well. And then, yeah, I mean, same situation, right? It's just going to take in, I guess, a pointer of this, because I mean, imagine it's going to be the same kind of API as it did here. Let's copy this code so that we find the field now. We've got the field, and then let's change this to be set value. And if we take a look at what it takes in an object field and, yeah, again, value, right? So it's exactly the same. This is just called value, and that's kind of it, right? So it can still return false, but in that case, it just won't do anything, so that's fine. And we can use that or not if we don't want to. So we can, like, because it's just going to silently fail, I guess. But that's kind of it. Like, that seems like it. I mean, how quick was that, right? Easy. Making game engines is easy. All right, why is my code not compiling? So we want to take in a void pointer value. Yeah, that should be fine. Can I convert argument 2 from const t to void pointer? Oh, yes, yeah, we should take in a const void value. Let's do that. F5. Failed. Mono set value cannot convert something to something. Ah, but see, mono are nice enough to not want to take in a void pointer. Why not? Why? Well, this is dumb. I'm just going to, you know, cast this to a void pointer. So I'm being a bit naughty with my const, but like that's because mono's API is stupid. Sorry, mono people. All right. So, check this out. So at the, yeah, actually let's go back to what we had in our game. I'm gonna not set speed to 0.25. So speed right now is actually 0, right? So we actually won't be able to move, but the idea is we're gonna try and set it like through the UI. So if we take a look at this, we don't have anything obviously yet. Now, if we make the game, you know, if I use the WASD keys, nothing is working. But what I can do now is I can obviously increase our speed. Let's set it to like 0.01 or something. And now check this out. I can move, right? And then if I go back here and I set it to like 0.5, right? Then I can move even faster, as you can see, right? That's actually pretty wild. So there you go. Easy. Easy. Back to 0.1. And we're back to 0.1, right? So I'm now able to like set variable, like both read, so get variables from the C# runtime during the runtime and also set them. The only thing that we would want to do differently, and this is kind of like, for those of you who are actually following along with this, making your own engines at home or whatever, this could be a good exercise for you. But basically, then this is probably what we're going to do next time, because we're going to finish up here. But basically, what we need to do is, at the moment, we only support doing this while it's actually running. So obviously our game right now our engine is in play mode. We're running this stuff. You know, we can see these things here. It's been running for like 75 seconds and everything is great and all that. But when we hit stop, and in fact, before we even hit play, none of this stuff is here because it doesn't exist, right? Because we can't get or set those fields at the moment because it's not running. We haven't created the actual entity instance yet in the C# runtime. We do that when we hit play. And so now it exists, obviously, and you can see the time's been reset and all that, obviously, because it's a brand new instance. So what we want to do is we still want to be able to display these fields here and set them to whatever we want, but it's not going to directly set them into the mono runtime, into the C# runtime just yet. it's just going to set them as values. So it's kind of like a map you've got of just like, you know, the name of each field, such as speed and time, and then your appropriate value. And then what happens is when you hit play, when it actually does create that entity instance in the C# runtime, it needs to go through your values and set it into the C# runtime as it creates this entity instance, right? So that's kind of how that's going to work. Nice little homework exercise for those of you following along at home, and something that we will cover next week. So yeah, that's that. I'm obviously going to push this code. It'll be on the scripting branch. In fact, I guess we might as well just go through what we've done today, because I hate, well, like, I don't hate, but I always forget to like push at the end of the day. So if we go back to this, let's take a look at what we've done. I'm not going to push the font size change, of course. Quite a lot, actually. So this is everything we've written inside the script engine class. Yeah, just extending this obviously to deal with the actual setting of values, as well as being able to read some of these types, which is good. Hopefully I haven't made any like typos or whatever here. Looks pretty good though. I'm still not sure if we'll stick to like short, int, long, and, you know, byte and stuff like that, or if we'll just change it to be like, you know, int 32 and 64 like it is for these. That might be nice. I don't know. Let's add those. And camera player, I mean, yeah, I don't know. I guess I won't commit this, because I guess we didn't even have a single public field before though. Yeah, I guess I'll commit the example as is. Just because it's kind of like testing stuff, and this is a scripting branch after all. And then scene hierarchy panel, we obviously added this ability to go through and display floats and edit floats actually as well, which is pretty awesome. And that's it. That looks good. So let's see. Retrieving public C# class fields. C# entity class fields. Also setting values during runtime. Okay, so that's all pushed to the scripting branch. Feel free to play around with that. Hope you guys enjoyed this episode of the Game Engine series. If you're watching on YouTube, please don't forget to hit that like button. Helps me out, makes me feel good about the series. It's a small price to pay. Next time, as I mentioned, yeah, we're going to resume our C# scripting, and probably, aside from doing what I said as like the little exercise, meaning like the you know, the being able to set them like before the runtime and play with them like during edit mode, and then we'll set them into the runtime. Aside from that, we'll probably expand it so that it deals with more types, because at the moment obviously we just support floats with the actual UI, even though we're retrieving, I guess, you know, we're storing all of the fields, but we're just able to set and get floats. Well, no, actually the thing is, it's kind of like half and half, right? Because if you look at the implementation here, get set value internal and get field value, like the thing is, this gets anything really, because get field value internal just calls mono get field. It doesn't care what type it is. It gives you a void pointer, right? It's just we're using the template to then cast it to whatever we want it to be. So because of that, you know, technically speaking, you know, if I wanted this to work with integers, it's just the UI. It's just instead of drag float, you would use drag int, right? And then you would retrieve, you know, you could do something like int and then get the value as an int, right? So it does, like, this API supports it, but the UI we've written only works with floats because we need to tell IMGUI what the format is, basically. So that's really the only thing that's stopping it. And obviously if you had like a vector2 as an example, you could use a drag float 2, right? So you could even have like a little mapping if you wanted to, or function to function or whatever, because at the end of the day, it does just take in, or like type to function, because it does take in that kind of data pointer, or, you know, whatever your data type actually happens to be. Anyway, thank you guys for watching, and I'll see you next time. Goodbye.